A group of rocketeers from NASA, Virginia, routinely visit White Sands to assemble and launch small scientific payloads into space. NASA has a program called Sounding Rocket, which was set up to be a low-cost, high-risk operation where rocketeers would take a few more chances in order to get the speed and the turnaround time that the experimenters were looking for. Multiple segments that control vehicle ignition, guidance, telemetry, recovery, plus an X-ray telescope, all fit together to make up an 18-foot payload. Everything is tested before assembly on a shaker device to duplicate the vibrations and rigors of launch. Simulations are used to activate the payload's protective door, revealing the telescope sensors. The ability to go into space provides sounding rockets with their unique view, clear of the distorting effects of the Earth's atmosphere. While they escape the bounds of Earth for just a few minutes, that's long enough for University of Colorado student Dennis Gallagher. He designed the mission to collect information on a binary star. The twin star, called Scorpius X1, has an intense gravitational field which heats matter to millions of degrees. The sounding rocket's telescope is able to read X-rays coming from it, providing data on the star's physical makeup. Fully assembled, the half-ton of instruments are stacked upon 2 tons of rocket motors, and the count begins. This is always a tense time for mission controllers, right until a successful launch. Throughout a flight, scientists take data for 7 minutes before the payload starts plummeting back to Earth. It lands downrange, 50 miles from where it was launched. At first light, helicopters deploy for the recovery. Today, the crew is lucky. The payload is intact with barely a scratch on it. In no time at all, it is unbolted into manageable sections for the flight back to the installation. After changes and improvements, most payloads end up flying over and over again. It's a low-risk way to launch experiments into space quickly and at minimal cost.